Hi everyone, I'm Subhash. I'm working on technical part of this project and I'm also leading this team. Now let me explain about the product and its working.
The main takeaway of our idea is to develop brain-computer interface for paralysis people. The main objective of our proposed project is with BCI between paralyzed person and device and send the received information in the form of message to caretaker. The basic problem of a paralyzed person is the communication of his needs to his caretaker. BCI can be viewed as a permanent solution and also suitable for those patients. The problems of paralyzed people are: normal people can express their feelings by saying it, but the paralysis people cannot say it because their motor nerves are affected. We overcome this problem by developing a practical BCI paradigm to enable binary communication of patients. And I'm going to list the components we have used. It includes components developed by Texas Instruments, and there are some non-Texas Instruments components also we have used. The Texas Instrument components we have used are BeagleBone Black Wireless and AD converters. And non-Texas components we have used are brain-computer interface, GSM module, Bluetooth and LCD display. BCI is usually a very complicated control measurement. During this process of measurement of brain signals, many problems arise at the stage of signal acquisition, signal processing, and in controlling the device. The recording of brain's electrical activity over a period of time is called EEG signal. EEG signal is nothing but electroencephalography. At first, the brain signals are fetched from the brain through EEG signals. The measurement of these EEG signals are very difficult because these EEG signals are very small amplitude waves. It is in microvolts. The position of electrodes will also be crucial in this stage. These EEG signals are digitalized and sent to the most important stage, the digital signal processing stage. It has two blocks: feature extraction, translation algorithm. The feature extraction algorithm are based on frequency analysis. It is nothing but DFT, and higher order statistics HOS, also in connection with the wavelet transform and auto-aggressive model. DFT operates based on freely selected portions of signals. For each time discrete Fourier transform is calculated. In translation algorithm, it takes the abstract feature vectors from EEG signal, which reflects the specific aspects which encodes the message a user wants for communication, and transforms these vectors into application device command. The goal of the translation algorithm is to maximize the performance of the application. Through the external receiver, the caretaker of the paralyzed person can communicate or know what the person is trying to tell easily through GSM transmission or via speaker. EEG aspect introduces some of the core aspects of EEG based BCIs. It explains why EEG is a popular technology. BCIs along the generic challenges associated with EEG signal processing. The brain activity recorded via EEG is typically classified into five different types, depending on the predominant frequency content of the signal, summarized as follows: delta activity, theta activity, alpha activity, beta activity, gamma activity. Through these activities, we can innovate this project. Common spatial pattern is one of the most common feature extraction methods used in machine learning EEG classification. CSP is a spatial filtering method used in transform EEG data into a new space where the variance of one of the classes is maximized, while the variance of one of the classes is maximized and other classes is minimized. The aim of this subsection is to provide a brief summary of the various classification techniques used in literature. Support vector machines and LDA were observed to be widely used because in the literature with the performance of the SVM classifier found to be superior when compared to various classifiers such as LDA, KNN algorithm, naive-Bayes algorithm and regression trace. The average classification of the proposed method using the support vector machine algorithm classifier was 96.2%. Therefore, we have used support vector machine classifier because its accuracy is 96.2%. Let me tell impact of proposed solution. The biggest impact of proposed brain-computer interface on paralyzed person is that the BCI reads the brain's blood oxygen levels and enables communicating by deciphering the thoughts of person who are totally paralyzed and unable to talk. This brain-computer interface works on electroencephalography, which measures the electrical activity on different parts of the brain of a person, and visual traces on oscilloscope screen. Thus, BCI involves the process of acquiring the brain signals, analyze them, translate them into commands that are relayed to output devices that carry out desired actions. Brain-computer interface, which is invasive, could transform the lives of such patients and allowing them to express feelings to their loved ones. We are still working on the product. We are still researching on brain-computer interface and collecting data from various hospitals. And we are consulting neurologists and getting data from them. And to develop product would take some time. Thank you.